Okay, so for the first one over here, what we're doing is we're graphing this system and we're going to see where they cross. So this top equation, where do we start? Positive 7. So 1, 2, 3, 4, 5, 6, 7. From there, where do we go? Down 2 over 1. So we're down 2 over 1, down 2 over 1, down 2 over 1. I'm going to do it a few times just to make sure I stay accurate with my line. So the second equation, where does that one start? Negative 1, and from there, where does it go? Up 2 over 3. That's a positive 2/3. So up 2 over 3, right there. Where do they intersect? 3, 1. How many of you had 3, 1 for that? For those of you at the table by the door, does that make any sense to you?
No.
We graph the line for each equation, and then where they cross, that's the point that makes both equations true. So when we're solving a system of equations, the point is to find that one point that makes both equations true. Okay. Was it good for you? Okay. So for the second one here, second set, let's do the top equation first. To graph that, we're going to have to adjust it a little bit. What are we going to have to do? We'll subtract 3x. So what that's going to give us is a negative 2y equals 10 minus 3x. From there, what do we have to do? Divide by negative 2. So we get y equals what? Negative 5 plus 3 over 2x. So where do we start? Negative 5, and from there we go up 3 over 2. Up 3 over 2. So there is our first line. Thank you. The second one here, what do you have to do first with that one? Subtract 2x. So we get that y equals 9 minus 2x. What else? That's it. We just have to graph it. Where do we start? 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And from there we go down 2 over 1. Down 2 over 1. Down 2 over 1. Down 2 over 1. And where do they cross? At the point 4, 1. How many had 4, 1 for that one? One of you? So it's a little bit more of a struggle when you got to solve them. Just got to be very careful. How many of you had the right equations here, at least? A couple of you? A few of you? Okay. So that appears to be the holdup, is getting from one of these equations and solving it for y equals. Is causing you some issues yet?
No, it was just like, it didn't, maybe my graph was just off, so it didn't look like it landed on it.
Okay.
It could have been that, but I don't know.
That might have been. That's why you notice I keep counting down and over or up and over, so I at least have those points.
Yeah.
So for a little bit of review for those of you that may not have been here yesterday.
Funny.
Thanks, sir. So what we're doing, is we're looking at taking two equations here that are lines, linear equations, and we're solving a system of linear equations. And what that means is we're looking for numbers or sets of numbers, ordered pairs, that make both equations true. And there's three possibilities. Either we have lines that intersect, so that there's one solution where they intersect. We have lines that are parallel, so that there are no solutions. Or we have lines that lie one on top of the other, so that every point on the line is a solution to the other one. So all the points are solutions. So for this system of equations, one of the method we went over yesterday for solving these was to graph them. And both of these are in easy graphing form. Y equals 1/2 x plus 1. Where do we start? Positive 1, and from there we go up 1, over 2. And there is the line. For the second one here, y equals 2x minus 2, where do we start? Negative 2. And from there we go up 2 over 1. Up 2 over 1. And we find that those two lines cross or intersect at, in this case, the point 2, 2. Now, if these didn't come out to be an exact grid point like that, integer coordinates, if they're fractions or decimals, obviously this would be really tough to graph and get an exact answer. It'd be almost impossible to do by hand. Even the calculator would be tough. Question, Mike?
Isn't there a way to do it without graphing?
Well, glad that you asked that. At the solution to this system of equations, this y and this y better be the same number, right? If it's a single point. So we can just assume that this y and that y are equal. So if this y equals this y, that means this must equal that. So 1/2 x plus 1 must equal 2x minus 2. This is what we call substitution. We knew that this y equals 2x minus 2, so we just replaced this y with 2x minus 2. So now we just have to solve this, and we'll have our value for x. So I have to get rid of one of the x's. I'm going to get rid of the smaller one, the 1/2 x. That's gone. 1 equals minus 1/2 x. 2 minus 1/2 is 1 1/2 x minus 2. Then what will we do? Plus 2 gives us 3 equals 1 1/2 x. Then what? Divided by 1 1/2. 3 divided by 1 1/2 is 2. X equals 2. Now, once we know that x equals 2, we have to come back to one of these original equations and figure out y. Now, I'm going to do the second one because there's no fractions in it. Y equals 2x minus 2. And since we just found out that x equals 2, I can replace that x with 2. So y equals 2 times 2 minus 2. And now it's simply order of operations. What is 2 times 2? 4. 4 minus 2 is 2. So y equals 2. So x equals 2, y equals 2 gives us the point 2, comma, 2. Not so bad? So we can use this algebraic method. This is called substitution, where I'm going to solve the variables, and I don't have to solve both variables. I only have to solve one variable. But I have the variables, one of the variables solved for, and I replace that variable in the other equation with that expression. Let's do some other examples. Looking at one like this. Right now, this is not in y equals form. I could solve both of them to get them into y equals form, but I don't have to. What I notice is in this second equation, y is not multiplied by anything. So I can solve for y without getting any fractions. Does everybody see what I mean there? Since it's really a 1y, I'd be dividing by 1, so I don't get any fractions out of it. So to get y by itself here, I'm going to subtract 2x. So this equation now becomes y equals 9 minus 2x. That comes from this equation right here. What I'm going to do is I'm going to take this, I'm going to put it back into this equation, the other equation where the y is. If y equals 9 minus 2x, then this y also equals 9 minus 2x. So I'm going to substitute 9 minus 2x in for that y. So 3x minus 5y, well, y becomes 9 minus 2x equals 7. Now I'm going to pause there. Does everybody understand how I got from here to here? Any questions? All I did was I took this other equation here and I solved it for y right here. And then I just took that expression for y. I use it to replace this y. Now I have to multiply this out. The 3x doesn't change. Negative 5 times 9 is a negative 45. Negative 5 times negative 2x is positive 10x equals 7. Now what? Well, we want to combine our x's first. 3x and 10x make 13x. Minus 45 equals 7. Now we could probably get rid of the 45 by adding 45. So 13x equals 52. And then divide by 13. X equals 4. So we now know that x equals 4. Are we done? No. What do we still need to know? Now we got to figure out what y is, and to do that, we're going to put 4 in for x in one of the equations. Fortunately for us, we just solved one of the equations for y, so it's really easy to find y from x. So we're going to take x equals 4, and we're going to come back to this first equation that we solved and put 4 in where the x is. So instead of 2x, it's now 2 times 4. So y equals 9. 2 times 4 is 8, so 9 minus 8. And we'll go ahead and subtract. 9 minus 8 is 1. So x equals 4 and y equals 1. So the solution is 4, 1. Any questions? Nap time? It does feel like it's been a long day already, doesn't it?
Yes.
If it makes you feel any better, I'm stuck here till 8:30 tonight. It does kind of some days.
Well, it doesn't because you don't have Christine coming in saying you have 10 days to finish your project. All you have to do is just finish the whole project.
Yeah, that does suck.
You get most of your thing moved up. So I was like, actually, Mike has like 3,000 euros. That's about it.
Sure.
No. Oh, yeah. But I just got back to it.
So, something like this. If I want to do substitution, remember I have to have at least one of the equation in the form of a variable on one side and an expression on the other. Now I look at that top one, the y looks like it would be easy to get by itself, but it's not as easy as it looks. Can you tell me why? There's a negative in front of it. That's technically a negative 1 times y. So it's not as simple to get y by itself as it looks. But it doesn't have to be y that we get by itself. In the second equation, you can see it would be fairly simple to get x by itself, wouldn't it? So let's do that. How do we get x by itself here? I just subtract 2y. So I get that x equals negative 6 minus 2y. So what am I going to do with that? I'm going to replace this x with that expression. So I'm going to rewrite that. Instead of 3x, it's 3 times negative 6 minus 2y. Minus y equals 10. Now what? Well, 3 times negative 6 is negative 18. 3 times negative 2, or negative 2y, negative 6y, and then we still have minus y equals 10. Now here, this can be a little tricky. The negative 18 doesn't change, but we have negative 6y minus y is negative 7y. Remember, that's a negative 1. So negative 6, negative 7, negative 1 make negative 7. So negative 18 minus 7y equals 10. Now what? Add 18. So negative 7y equals 28. And then divide by negative 7. So y equals negative 4. Now what? Yeah, plug that back into this would be the easiest one. I can go back to any of the original two if I want to as well. But this one here would be easier because it's already solved for x. So x equals negative 6 minus 2 times negative 4. The negatives here can be kind of clumsy, but we have the negative 6 here. I'm going to treat this as negative 2 times negative 4, so I get a positive 8. Negative 6 plus 8 is a positive 2, so x equals 2. So that is 2 comma negative 4. Questions? Too many to ask? You doing okay? No? Need to cry a little? Try that one in your notes. See if you can solve. For this one, what'd you guys get?
Negative 1, 2.
Negative 1, 2. Okay. So how do we approach it?
Solving one equation.
We can pick any equation and any variable. It'll work. It's just you want to try to pick one that's the neatest. And usually any variable that has a coefficient of 1 or no number in front of it is the easiest one to solve for. So which equation and which variable is going to be easiest here? The y in the second equation, right? Again, you could pick any variable, any equation. It'll work. It's just going to get uglier with fractions and stuff. So how would we solve for y here? First of all, does everybody understand why we would solve this one for y? Because you're not dividing by anything, yes. Does that make sense, Mike? So now to get that by itself, we have to add the 3x. So y equals 5 plus 3x. And now that we have that, what are we going to do with it? Go to the other equation and replace the y in that equation. So that is now 5x plus 2 instead of y. What are we going to put in here? 5 plus 3x equals a negative 1. Now I'm going to pause there. Anybody not sure where that came from? I just replaced this y with that expression. Now what do? We'll keep the 5x and we're going to multiply through the parentheses by 2. 2 times 5 is positive 10. 2 times 3x is 6x. Now what? 5x and 6x make 11x plus 10 equals negative 1. And then subtract 10. 11x equals negative 11. And then divide by 11. X equals a negative 1. So x is negative 1. How do we find y? We're going to use that one. We can go back and again, we could go back into either of the original equations if we wanted to. But I'm just going to put it in there. So y equals 5 plus 3 times negative 1. 3 times negative 1 is negative 3. So plus a negative 3. 5 plus negative 3 is 2. So y equals 2. So yeah, negative 1 comma 2 is the solution to that equation. What do you guys think? A little complex? Okay. We'll hold off on the new quiz till tomorrow.
Oh, wow.
The new quiz will be on graphing systems, by the way. So we'll review that again tomorrow. What's that?
Turning a leaf over in this class.
Yeah, I'm trying to be nice. In your big book on page 411, exercise 17-2. I'm looking at 1 through 19 there. Give those a shot. We'll talk about this more tomorrow. We'll review graphing and substitution tomorrow, and we will introduce we will completely go over the elimination method tomorrow. And yes, there will be a quiz on graphing systems tomorrow, just so you know. That means we may not finish Unit 3 this week. But I'd rather slow down and make sure you guys understand this than keep pushing through it.